Okay. Yeah. Hello, everyone. And today I will talk about working architecture of Node.js applications. And at first, I would like to tell a little bit about myself. So, as I've already told, I'm a CEO and principal software architect at WebbyLab. And I'm in software development for more than 15 years. And during this period, I've delivered a lot of projects. And among them I had projects from at least 500 from Fortune 500 list. And all of these projects are rather different. And in my company, we needed some sort of architecture which allowed us to run these projects. And not only for Node.js, but for other stacks. And why do I talk about architecture? Because it's often underestimated, importance of software architecture, but without good architecture, you cannot build a large-scale application. The second thing is that you can find a lot of hello world examples in internet, and you can start doing your Node.js application, but you will finish with like one file, several files, but it's rather hard to find anything which will describe you and help to build a really large-scale application, or even small, but in a good way, which will allow you to support it in future. So, and a lot of people, like in JavaScript community, are from front end, and they would like to know how to structure backend code. And I want to share my experience. And I call this architecture working architecture because we use it in production for 8 years already. And as I mentioned before, we use it for Node.js, PHP, and Perl. Okay. So, I will talk about different things. 30 minutes, it's not enough to cover all the details, and I will start like with the basic ideas. But in any case, I will show real code and explain ideas behind the architecture. But at first, I would like to start with very popular questions: what to choose, monolith or microservice? And it's like who prefer to start with monoliths by default? Great. And who prefer to start with microservices? Okay, yeah, there is one guy. And before moving forward, I would like to ask you what is the most popular architecture today? And I have an answer for it, and it's like statistics. The most popular architecture is like big ball of mud. And it's a common situation, and you can see a link at the slide. You can read about this article. It describes why it happens. And a lot of people think that they have this architecture because of monolith. But in real, with microservices, you will have big and distributed ball of mud. And it will look like this. Okay. And there is a great quote from Simon Brown, and he says, like, if you cannot build a monolith, what makes you think that you can build distributed microservices? Because it's much harder to build microservices than monoliths. Like another quote saying that, like, poorly structured monoliths can be converted in poorly structured set of microservices. Yeah, you can build, in real you can build, and it will look like this if you will make everything right. But it's not an easy task to deal with all of this. And we have a lot of microservices drawbacks, like high operational complexity, version compatibility issues, especially you will feel them when you will need to downgrade one of your services and to preserve compatibility with other services. It's extremely hard to support transaction. Usually you have, like, for every microservice, you have a separate storage, and it's extremely hard to make everything, one request atomic, to update all the storages. You have, like, a lot of issues. Moreover, you will need more experienced team to manage and to deliver microservices. But all of this you can solve. There are some tooling, etc., and you can start with microservices. But there is one thing that cannot be solved, and before moving to it, I have another question for you. Like, what is the best architectural decision? And there is a great quote of Robert Martin, and it's like my favorite quote about architectural decisions. And he says that the best architectural decision is that one that was not made. So how to understand it? The key idea is that when you start your application, your architecture depends on a domain knowledge. So with better domain knowledge, you can create better architecture. But at the beginning of the project, you do not have enough information about your domain. And architectural decisions are rather hard to change. And if you can postpone this decision to a later stages, then it will be better because you will have more domain knowledge. And like Job Martin says, the job of architect is not to make decisions, but is to defer decisions as long as possible. And good architecture maximizes number of decisions not made. And in case, if I'm talking about microservices, you expect that you can make all of this decision in advance and like split your large application in a correct way. But usually it's not true. And it's much harder to do refactoring. So because of this lack of domain knowledge, you will have a lot of refactoring, like moving pieces of your code from one place to another. But with microservices, it's much harder to do. Martin Fowler says similar. He says that, okay, refactoring is much harder, but another thing that if the components do not compose cleanly, then what you are doing is shifting complexity from inside of your components to outside, to a level of communication. And in this case, you will have like implicit complexity, which will be even harder to manage. Okay, so because of that, we start with monolith by default in 90% of cases. And it's okay to use microservices, but usually you switch to microservices. There are a lot of successful cases when you move from monolith to microservices, and and not so many successful cases when you start with microservices. I would like to tell you a small story. I remembered it yesterday during pre-party, and who uses GitLab or heard about GitLab? Okay, so I'm from Ukraine, and GitLab was developed by Ukrainian guys. And at first, we have GitLab and GitLab CI now, but at first it was only GitLab, large monolith. And later they decided to create GitLab CI, a separate service, like another large monolith, like two large applications. And at one day, CTO came to CEO and said, like, we have an issue. We have like one large monolith and another large monolith, but for further development, we need to do something with it. We need to merge these two applications in super monolith. And they did that because it provided more value to users. Now you have GitLab and a lot of GitLab CI metrics inside of the GitLab application, and it works better, provides more value. Okay, so what is monolith? How should it like? Usually it looks like this. So it's not one process. You can have your backend with storage, but you can have different workers. You can use job queue, like RabbitMQ or any other. You can have mail worker, report worker, etc. You can have different services which will be integrated via REST API or GraphQL API with your backend. It's like standard approach to split this. And in future it can look like this. So it's one of our projects, but we have a lot of services here, but the idea is that we have core, and core is a key service with a database, and it handles all the integrity of the system, of the whole system. But in total, here we have more than 30 services. Okay, another question. A lot of people ask which web framework to choose. I've tried a lot of these frameworks, and the answer is, in real, it doesn't matter. So your application architecture should not depend on a web framework. And this is not theory, but we do it in practice. So we can replace Express, so we use Express, but we can replace it with another framework. In our company, we use Express for Node.js, Slim for PHP, and Modulicious for Perl. And a lot of people ask, we use MVC, and why do we need another architecture? Architecture that I would like to show, follows MVC pattern, but what I see in JavaScript community is that a lot of people do not understand what is MVC. A lot of people I did a lot of interviews, like several hundreds, and usually if you ask what is MVC, a person can describe what is it, but if you will ask a practical questions like this one, for example, where to place this code, in a model or controller, it's like a small piece of code will calculate text. Who will place it in model? And who will place it in controller? Okay, much more people, like 80% of hands were for controller. And there is a name for such type of controllers, fat, stupid, ugly controllers. You can find a link to this article in Wikipedia on MVC page, in the page describing MVC. So the idea, you should never put your business logic into controller. And it's a common misunderstanding what I see in JavaScript community. Okay, so another question, is model and domain model the same? A lot of people think that it's the same, but different things. So a model from MVC perspective is your domain logic, but domain model is the way how you organize it. And you organize it in a different way. Like you can use domain model, you can use transaction script, table model. Service layer is a part of model from MVC perspective. So controllers should be extremely thin. Okay, so domain model, it's when you have your business logic in a form of classes. Objects and classes. It works well for medium and large scale application. You can organize, there is another approach, transaction script, and it's when you have your domain logic in procedures. And it works for small projects. So you have a procedure for each request, and that's it, without any object-oriented programming, etc. Okay, so this picture is from Robert Martin Post's Clean Architecture, and our architecture is inspired. I can say it's inspired because we've started it even before the post was written, but in any case, it follows the same ideas. So what is clean architecture? We have layers here, like circles, and inner layers. The main idea is that inner layers know nothing about outer layers. For example, entities know nothing about use cases. Use cases know nothing about controllers. You have even more layers, and it's fine. In our case, it looks like this. So we have a data access layer, domain model, and services. And everything which is in green belongs to model from MVC perspective. And the next diagram. So as I mentioned before, our application should not depend on a web framework. And here we have web framework boundary. So everything below this boundary know nothing about web framework, know nothing about HTTP protocol, know nothing about JSON, XML, etc., transport. So only controllers know about, and they're extremely thin, only controllers know about HTTP. And the key idea of controllers is just a glue layer, and they should be extremely thin as possible. So you can replace, for example, so if you will need to change your JSON API to XML or even create command line interface, you will need to change only controllers. You will reuse services and domain model, 100% of your application logic you will reuse. Domain model, as I mentioned before, it's core part of your application, and you should have almost of your business logic there. Not only database access. A lot of people think that if they use ORM, then it's only for database access. Not, it's not only like for data, it's for behavior. Because you have like your object model, and ORM allows you to map it into database. And you should add like methods with behavior to your ORM classes. Moreover, domain model can contain not only like not only ORM classes, but your domain model can contain custom classes. It's absolutely fine. And the key idea is that this like is your core part of your application, and it has fine-grained API. So you have, for example, user, and user has first name, last name, email methods. It's convenient to use to have these methods, but they are not suited for remote invocation. You will not do like separate network call for getting first name, another one for last name, etc. And the key part is services. They belong to model layer, and they contain application logic. So we have domain model with business logic, and we have services with application logic. So each service describes a use case for your application. And it knows about context, like which users make the call. And you can check user permissions, etc. And it has coarse-grained API, well suited for remote invocation. Okay, how much time do I have? Okay, 10 minutes, great. Let's look at the code. So we have enough information to understand the code. How do we cook the service layer? We have several rules for service layer, for building applications, and the first one, like every service is a separate class, implemented as a command pattern. So here we have a service post create, which will create a post, and every service has only one method, run, and that's it. And you can pass parameters to run methods, user parameters, and you can pass context like user session or like other dependencies to constructor. So one endpoint, one class. Here, can you read it? Okay. Yeah, it's an example of controller. This controller has like 5 use cases. Like it imports 5 services, and like we have create, update, delete, list, show features. And what we have a small util make service runner. It takes a reference to a class and the function which will extract parameters for run methods. So for create, we will get information from body. For delete, we will get information from URL. We will take ID, and we'll run post delete, create an object, and call run, and pass this like parameters to it. And that's it. So controllers are extremely thin. Okay, let's take a look at a service class. Every service class inherited from a base class, and the base class has this run method, and it's a template method, and it does several things. It's the simplest version, but what we see here, we have like run method which runs validate, and then it calls execute, and execute will be called only after validation. If validation was not successful, execute will not be called. It's one thing. Another thing that you have parameters here, and execute will get cleaned params. It means that if you do not have validation rules for any field, it will not go to execute. And here is an example of post-create service. So every service looks absolutely the same. It's very easy to support them, to add new services, and to add new features to application. And it contains like validate method and execute. Validate is for validation, execute for execution, and that's it. You can have several, like you can add static property like required permission, and you can check user's permission in run methods too. It works well. Okay, what we see here, we have like declarative validation. We create here post and return some data, and we use dump post function here. It's very important, and I will return to it later. Okay, run methods I've already described. Run methods described it. Okay, let's move forward. Yeah, rule 2: never return objects directly. So you should not return your domain model object from execute. You should return data to your controller. It's the first thing. And you should have, like we use this dump post, which has a wide list of properties. Why it's important? It's important because without it, you will have unstable API. Any new property which will be added to a post will break your API. But in this case, it will behave like the same. Moreover, it's a question of security. You can have internal data, like, for example, if it will be a user object, you can have hash of the password, for example. And you should not return it. And having this like dumpers allow you to have more secure and more stable API. Rule 3, we use, and I can say that there is no excuse for not using promises or async await today. And it's not because of like callback hell, but the key feature of promises and await async is approach to error handling. Now you can handle your errors in a proper way. And it's the most important feature of promises and async await. Unified approach to validation. So never trust any user. We use declarative validation. We exclude all fields that do not have validation rules described. And we use Lever for validations, library that supports JavaScript, Perl. In real, it's a specification, and we have implementations for JavaScript, Perl, Perl 6, PHP, and a lot of other languages. And as I mentioned before, we use the same architecture for Node.js, PHP, and Perl, and this library allows us to have the same structure. And rule 5, be aware of anemic domain model. So what is anemic domain model? It's a common mistake, and you can find this article and read it. It's written by Martin Fowler. And the key idea is when you have your domain model, but you have only data access in your domain model, and you place all of your business logic into services. And in this case, you like switch from a domain model approach to transaction script approach. And it will not work for medium and large scale application. And it's a common mistake. And it, sorry? Okay. And I would like to show you a little bit of Perl code. Do not be afraid. So I just want to show that it looks very similar. So we have validate method here with validation, and we have execute method here with like our main use case described. And we have required permissions. So to run this use case, user should have write access to master data banks. Yeah, let's execute. Okay, GraphQL support. It's another thing, very popular thing, and a lot of people talk about it. And we have different approaches, like we have Prisma and so on. But Apollo server, but in our company, GraphQL supports look like this. So it's like REST API support, and this is GraphQL support. REST API, GraphQL. So you see the difference. Okay, we have like GraphQL is just like a front controller, like a router in Express. So here we have front controller router with controllers. Here we have GraphQL server with resolvers. But we reuse the same services and the same domain model. And we can change it even for like SOAP or any transport. And we will reuse the same code Moreover, we can support at the same time both REST API and GraphQL. Okay, let's take a look at a full example of user registration. We start with the post router, and we have a post users root, which will call controllers users create, which we have similar controller here. Okay, service. It looks a little bit different now. We have static property validation rules, but the idea is the same. We just decided to have a static property and a fallback to validate a method in case of need, because it's like more declarative. And we have execute method. What we see here, the most interesting part here, we have this action object, and we send email to a user to verify his email. And this action object is a way how we implement persistent callbacks, which can be called over the network. So it's the same approach we use. It's a rather interesting approach. I'm not sure that I have enough time for it, but the idea is that it allows us to handle password recovery, email verification, and a lot of external actions. It's user model. It's rather simple, but we have several plugins here, like timestamps and user password. User passwords provides methods for working with passwords, and it provides hashing, salt, etc. We use bcrypt for hashing, by the way. Okay, it's an action model that I've described before, and that's it. So it's like the key ideas. I understand that it would be great for you to see more code and to try it in practice, and we have a plan to open source this. Okay, but at first I just want to repeat that this architecture allows us first of all to work on small and large projects. Moreover, it's easier for us to switch people between, for example, PHP and Node.js. Moreover, more experienced people from Node.js can help people from Node.js and in opposite direction, so better knowledge sharing. And yes, we have these services in our application already. It's not very hard to extract one service in a separate process, so it works well for it. And I have several, so we do not have time for questions, but I have them here in my slide. And 3 questions that people often ask about this architecture. Do we use 12-factor approach? Yes, we do it, and it's a part of boilerplate. And is it okay to call a service from service? We usually do not do this, and if you need this, possibly you need to move some part of your logic into the main model and reuse it from that layer. And is it okay to place methods and behavior in sequelize model? Yes, and that's the idea of the ORM. And that's it. I have several useful links. And as I mentioned before, we have a starter kit inside of our company, and we use it for many years, but the idea is to open source it, and it will be open sourced in 13 days. It's ready, but we want to add more features, more documentation, and if you want to get it, it will be announced on my Twitter. So subscribe. And that's it.